Hello, what's up guys? I do hope that you're doing great. Welcome back to a new video, and in today's video looking into a new topic, that is the acceleration. In the last topics we have discussed uh, the velocity and the speed with examples, and if you haven't checked out that video, do check that out because we are running a series of this all topics related to the motion, and all topics are very connected. Like acceleration is very linked with the velocity. Now let's see. I only that I told you velocity is the speed in given direction, like you're traveling in 20 meters per second towards the east. That is your velocity. I'm just telling you that definition. I just told you, but I have explained this in detail, so you can check that out. Uh, the velocity and speed video in my playlist of physics. Now let's move for the today's topic. What is acceleration? You are seeing a meter over here. This one meter. So what this meter is, you will get to know shortly. Like, why did I mention this meter? Like, I would say that first of all, uh, that you have heard your father maybe saying like accelerate the car or accelerate the bike. So you know the word accelerate is being used. That is, there is something, a practical use of acceleration as well. So that's quite interesting, and just get into it. First of all, let me write the definition and then explain you what does it mean. Simple definition of acceleration is rate of change of velocity. Now we have seen that rate of change of velocity, or we've got another definition, that change in velocity per unit time. This is acceleration, rate of change of velocity. Now we have seen that we have got velocity. I have talked in the previous video that here we have got a breaker. Here, for suppose we have got a breaker, speed breaker, then a velocity changes. So that is non-uniform velocity. So the rate of change of that velocity, you know how that is changing, and is it constant or all that, that is dealt by the acceleration. Acceleration is a change in the velocity, decreasing velocity or increasing velocity per unit of time, and that helps us to calculate the you know the movement, how fast we cover distance and all that. uh, you know, in our cars and all that, we are not having the velocity meters, we are having acceleration meters. Acceleration meters are showing us the change in the velocity, right? uh, Now let's get into more into it. Acceleration is produced due to three reasons. Okay, so yes, there are three reasons for acceleration being produced. The very first is the change in velocity. We have discussed the change of velocity, that is acceleration. Now the second reason is a change of the direction. For suppose you are moving from here, and then here you got slow down, breaker, speed breaker is there, you got slow down, then again you got fast. This is this is a reducing point. Now your this is your or you can say that this is vi, and the initial, and this gets final, and f, and for here it gets initial, and here it gets final. This is a thing, like link the things. There is a change of velocity over here. For suppose here it is 20, here it is 10 meters per second, here it again gets 20. Now here we have got the differences, and this is acceleration, the change of rate, rate of change of velocity. This is acceleration. And what if I would say like uh, this is a car moving, and this moves in this direction, and here it is 10 meter per second, and now here it gets 13 meter per second. Now here this is a positive acceleration, because acceleration, I'm writing a to understand this. This is a positive acceleration because there is an increase in the rate of change of velocity. The 13, it got 13, it is over 10. Now what if uh, you apply brakes and you are being accelerated uh, toward, you are going on this direction, and here you got uh, 10 meter, here you got 10 meter per second, here you are 13. Now the acceleration direction is toward this is negative direction acceleration, right? This is negative acceleration because the direction is changed. This is the second factor, and the both can also apply, like the magnitude and direction of the velocity can change, and that will cause the acceleration. Now if let us talk mathematical terms about it. So acceleration is uh, delta v, the change in velocity upon time, right? We have discussed this thing. A is equal to delta v upon t. Now uh, you know I'm gonna write a with a small a is represented by it, and that is equal to delta v upon t. And we are known that delta v, in last we looked in our previous video, what is delta v? Delta v is equal to vf minus vi. Vf minus vi. We are changing about change in velocity. So how the change in velocity means there are two velocities or more than two velocities, so that comes in the final elation. If it would be same all around, how there would be an acceleration? So we can write that acceleration is equal to vf minus vi upon t, minus vi upon t, right? This is the formula. And if we talk furthermore about the units, so the units can be meter, the velocity is for meter per second, meter per second. This is the unit. Meter acceleration is equal to meter per second square, meter per second square. Now why did the square came? Do you have any guess? Now we have looked into our previous video that velocity formula is uh, distance per unit time. So in other words, you can say acceleration, that is very deep, we just not want to go over that much deep. I'm just explaining you this. You can write s upon t minus s upon t. Now it got upon t. Now here we have got uh, the t is common, and here we have got the t square or the second square. And now let's look more into it. Like you if this is confusing you, let me move it and make it more simple. Delta v upon t, delta v is equal to meter per second, so meter per second upon second, this is the thing, and this gets into meter per second square. This will lead it to you to do this. And now I want to explain you something else. For suppose we have got a body here, and we have got a second body over here. Now what's happening is this, for suppose this is traveling with velocity v, and acceleration is equal to a in this direction, and we've got a velocity v in this body, and acceleration is in this direction. This is the same thing I've just explained you over here. This is positive acceleration, negative acceleration. This is how it works, the positive and negative acceleration. And in the positive acceleration, the speed or the velocity increases, while the negative, it decreases. This is the same as Emil explained in terms of that. uh, you know uh, for that, suppose I've got another point for you. That is a beautiful diagram where it shows uh, acceleration and the time. uh, Uniform acceleration. When is uniform acceleration possible? Of course, when we have got the uniform velocity, then we have got the uniform acceleration. And uniform acceleration, what does it mean? There is a no acceleration, change in acceleration in the time per unit the time. Then we have got this sort of graph straight. Then we have got non-uniform. The velocity gets increasing and decreasing. For suppose you are got into a speed breaker, so in this case that would be a curved path. This sort of graph would be there. So that was kind of about it. And this is also showing like this is a unit is different, but in our cars we have got other units as well. You can check that out. Like you have written that miles per hour, kilometer per hour, and you are traveling with that. And yeah, uh, that is kind of about it with you guys in the next video. Till that, goodbye.